Welcome back to Advent of Code 2025, Day 2. The problem reveals itself in 2 minutes' time. So last time we had this problem about a rotating safe combination thingy, which was a pretty good problem. So I saw another programmer suggest that they just added a really big number so that they didn't have to deal with negatives. That also works, but although you'd have to pick a big enough number. All right, got just a minute to go. Um, have a quick look at my private leaderboard. Fair few people have done the problems. Oh. Okay, 30 seconds. Oh, put the music on. Twenty seconds. Day 2, gift shop. You get inside and take the elevator to its only other stop, the gift shop. Thank you for visiting the North Pole, gleefully exclaims a nearby sign. You aren't sure who is even allowed to visit the North Pole, but you know you can access the lobby through here, and from there you can access the rest of the North Pole base. I mean, who owns the territory which the North Pole is? Isn't it in Canada? It's migrated, hasn't it? It's come down a bit. I think it's in Canadian territory. As you make your way through the surprisingly extensive selection, one of the clerks recognizes you and asks for your help. My famous programmer. As it turns out, one of the younger elves was playing on a gift shop computer and managed to add a whole bunch of invalid product IDs. Amateur. To their gift shop database. Surely it would be no trouble for you to identify the invalid product IDs for them, right? We've even checked most of the product ID ranges already. They only have a few product ID ranges that you'll need to check. For example, okay, so it's like that format. Since the young elf was just doing silly patterns, you can find the invalid IDs by looking for any ID which is made only of some sequence of digits repeated twice. None of the numbers have leading zeros. So just find all the invalid IDs. Got it. Alright. Seems alright. Okay, so the first thing we want to do is split this. So, There's just one line, isn't there? Line equals f.readlines. Or pair in line.strip.split, comma. So we split it on the comma. Strip. Line is have to read line. Split on the comma. Left, right equals pair dot split on the hyphen. And turn them into ints. Alright, so we've got ints, and then we want to say, so it's inclusive, isn't it? Probably. So we want to say, or, like, we don't, do we actually, how big are these ranges? For now, we can just do the brute force way, I think. But I'm pretty sure we'll have to be a bit smarter for part 2. For, let's say, for n in range, starting from left, ending on right, if so that the left part equals string so the ID, let's say it's the string form of n. So the left part is going to be ID num ranged from the beginning up to, let's say, mid equals length of how long it is divided by 2. So L equals that up to mid, and right equals ID num from mid onwards. And then we want to say, are they the same? If L equals R and wait, what do we add exactly? We add the ID itself. Yeah, add up all the invalid IDs. So n print result 1. Okay, try that. Correct. Part 2. The clerk quickly discovers that there are still invalid IDs in the ranges in your list. Maybe the young elf was doing other silly patterns as well. Now an ID is invalid if it is made up only of some sequence of digits repeated at least twice. So 1, 2, 3, 4, 1, 2, 3, 4. And 1, 1, 1, 1, 1. Oh god, alright. Okay. Wait, that's not that hard. Alright. So we want to, so we now have a generic, it can range, so for the number of tokens, or the number of splits, before it was 2. We would split it in 2. Now we can split it in up to, like, the number of digits. Alright, so basically what we want to do is have a K value here that ranges from 2 so left. Okay, we don't do this. Alright, so we say for pair in wait, no, this is right. So we've got our number. We're looking at a number. Alright, should we just do this outside? Make a method. Define is invalid ID for a given number. Alright, so then we take this logic out. We'll have 2 definitions. So this definition is this. So we're basically saying if is invalid ID n, we do that. Now we got number 2. All right, so for number 2, we want to say for K in range ranging from 2. See, this is going to be exponential, isn't it? Well, no, the number of K values is logarithmic in the... I don't know, we'll try and see. Yeah, no, it should be fine, because you can only have at most like that many digits. Okay. For K in range 2 to length of ID num. We just want to say is it split into all those parts? So if we now, so we're saying K is the number of pieces we break it into. We want to define an array, which is all those individual pieces. Right, so for this given value of K, we now want to say, let's create an array, and we say for, let's say, I in range K array.append ID num from I to I plus K. So those are all the pieces. No, not K. Hang on. What? No. This value here is like... Can we just... M equals length of ID num. this is going to be M. So piece length, the individual piece length is going to be M divided by K, I guess. So this is going to be I plus M. All right, so that is one piece. And then we have an array. We've just added K pieces, and now we want to say, are these pieces all the same? So we could either check, use an all identify a Boolean, or we could just say, if length of set of array is 1, that means they're all the same. Then return true. And then if we get through this whole thing without finding anything, we return false. Let's try this. This is taking much longer time, but okay, and that didn't work. Yeah, because we didn't return anything from here. Return. What? Huh? Ah, right. L is R. It's invalid if they're equal. And this is, I've used the wrong value here. Okay, so they were both broken. So it takes a lot longer. Alright, it's a bigger number because we're allowing more invalids. Oh my god, I didn't even have the bloody... Oh my god. Apologies for anyone watching the video. I just did a whole bunch of code without even showing it. What I did was this. Well, let's try the number first, then I'll talk through it. It's wrong. All right. Okay, so what was I trying to do? Similar to before, but we're allowing K to range from 2 to M, the number of digits. And for each value of K, we're creating an array, and in that array we're cutting cutting that string into pieces. Putting each piece in this array. I see. I see what's going on here. If and it's not an empty string, because if it doesn't evenly divide, like if we take a string of no, that's not the issue. Hang on. We'll have to test this out. So we have the correct answer for part 1, right? Okay. So like for the value 2, we've got piece length will be m divided by 2. So that's equal to mid here. And then for IM range 2, we basically create one of these and one of these, right? We do 0 to mid and mid to mid, essentially. We get 2 strings. So this array will always have one non-trivial string, because like if you divide the string into parts, at least one of those parts will be a thing, because it was something to begin with. Not if it's a single digit. Oh wait. It can be a single digit. Damn it. So if it's a single digit and you divide it by 2, hang on, what do repeated at least twice? Interesting. So for a single digit, this is an empty range, so that's fine. All right, so this was ended in 627. Let's try it again. Did that not change? It should have changed. No, because that was an empty range, so it wouldn't matter. It's correct for single digits. It's just automatically false. Alright, we're gonna have to try out a value, aren't we? Alright, we'll try the test case. We should actually print out the invalid numbers we find. Supposed to be one line. One, 13914. Wait, what? Huh? So that's the correct answer for part 1. What is that number? Oh my god. Okay, something's very wrong here. Okay. Fine. Let's say just print n and then print the array that I'm saying is length set, right? Was 1. Let's just see what these look like. So we've got 1 1 2 2 9 9 1 1 0. Oh, what happened here? We divided this into 2. Oh, I see. Oh, I see. I see. We're cutting off the last bit. So the last bit should be... Oh, okay. Fine. Yeah. Alright, so what we need to do is stop here. And then the very last piece, we have to add... just the rest of the string. Don't add a fixed amount, just the rest of the string. Try that. 111999. Better? Wait, no. Yeah, no, but it's not right. Why have I got such a terrible way of cutting this? Let's start this fresh. This is such a mess. Oh my god. What even is this? This is so wrong. Oh my god. I times... Wait, what? Okay, okay, okay. This is completely wrong here. Piece length is that. So it's gonna be... I times piece... Oops. Piece length. To I plus 1. Times piece length. Oh my god. Yeah, I was just looking at single digits there. And then this last one would be... not I. Oh my god. Piece length. Why did we choose such a long variable name? Okay. There we go. 417. 4174. Yep, that's correct. Okay, we had such a bad... I didn't test it. My bad. It's such a bad way of cutting strings. Okay, so to explain this bit, we're taking the number and then we're saying k is a number from 2 to the number of digits, and we're saying we're going to split it into k parts. So we choose the piece length, which is going to be m divided by k, but it may not divide evenly. That's why we have to have this extra step here. So, and then for up to, so the first k minus 1 parts are going to be fixed length, which are going to use the piece length, and it's going to be I to I plus 1. Oh, I think Python slicing probably has a way to do this, like in one line. Like you could use the every, it doesn't matter. And then but the very, very last piece, we just add an open-ended thing because it might not divide evenly. So we make sure we get the whole string split into pieces, and then do this. All right, fine. Messy. It's about double. Correct. So when you click stats, that many people have solved it. So we're like in the top 2,800 or so. Cool. All right. That was good, and I screwed it up a bit. It's early days. Yeah, because let me think about this for a second. Aha. Okay, there's a way cleaner way of writing this. Don't split it like this. Just say. Just take the first piece. Get rid of all this. Just take the very first piece. Don't need an array. Right. It's similar to... No, it's not quite. Right, so take the very first piece. First token equals... ID num up to m of k. So that's just the first piece. And now just say if ID num equals first token times k, so that would be the repeated string. Return true. That's it, isn't it? You get the same answer. 4414. Yes, and it's quicker as well. You don't need to faff about by checking each token. You just have to build what you think the pattern would look like if you're using that first token. So similarly here, we don't need to worry about it here. This one's fine. But yeah, this one's, you just take the first token and you say, well, if it was split into 7 parts, and this is what the first token looks like, then just multiply that by 7. So if it's 1, 2, 3, then it's going to be 1, 2, 3, 1, 2, 3, 1, 2, 3. And then check if that string is what we have. And if these ranges were really big, like these were really big numbers, and the ranges were in the billions and trillions, then you would have to do something different. You would have to actually range through possible token numbers. So you'd range from 1, 2, 3, up to like the hundreds and stuff, and multiply that multiple times and do something clever there, wouldn't you? Probably use some recursion somewhere. I've seen a problem similar to that, but yeah, that is a massive simplification. And it's super safe. Like, nothing can really go wrong here. These kind of overlap. You could say... Oh, no, we want separate methods for separate parts of the problem. Okay. Alright, good problem. How long did it take us? Again, about half an hour with reading and explaining. 10 days to go. 23 hours, 26 minutes to wait. How are we going to pass the time? Oh, it looks like they're building a... Where were we? A shopping mall? A gift shop for visiting the North Pole. Where is the North Pole right now? Where exactly is the North Pole? Because it migrates south, doesn't it? And eventually they'll swap places, and the South Pole will be... It's in the middle of the Arctic Ocean. Oh, it's not that far from the geographic North Pole. Wait, what? What's the North Geomagnetic Pole, and why is that different from the North Magnetic Pole? Oh, a compass doesn't point to the North Pole. It points to the magnetic North Pole. The geomagnetic North Pole is different from the magnet... What? Let's do some learning here. Okay, so the geographic North Pole is nothing to do with magnets, it's just basically the center of the Northern Hemisphere. Okay. The true North Pole. And then you got the magnetic North Pole. Is a point where the compasses point. Fine. And it moves. Right, we know that. Okay, fine, but what's the North Geomagnetic Pole? Oh, here we are. North Geomagnetic Pole. As a first order approximation, can be modeled as a simple dipole. What is the point in this? Why, if the compasses point to the magnetic pole, then why do we have this first order approximation? What do we use it for? Because the compasses are literally pointing to the North Pole, right? So the magnetic pole. Okay, whatever. All right, let's see who's doing the problems. Bad Cop is always doing it in Bash, which is really cool. Stew Squared. Okay, we raided Alka the other day. Let's have a look. Who's doing it in... he's using functional programming. That's cool. Tony Twitch. Temporal Alice. I've seen them before. Alright, let's have a look at Stew Squared.
Option.
I've raided them before, like last year. Is he doing this problem? Oh, he's doing an old problem, 2015. Alright, Tony Twitch. Okay. Let's raid Tony Twitch then. They are solving the same problem, but in Python. Wonderful. I don't think I can do the raid. I don't think we have enough viewers. Alright, never mind. Alright, so then the next problem will open tomorrow at the same time. Yeah. So see you then.